videoing?
Yeah.
Okay. Well, we're ORCA. We met with you a few times, so may not need to go through all the background, who we are, all these other things. Okay, so we're going to go through our significant progress in various stages, or what we expect to see, things like that, and any errors we've run into, and things we're currently having issues with.
Okay.
What we expect to show you in this demo is all of our deliverables besides the manipulator for the alpha software deliverable. We'll be talking about the IMU, GPS, video, temperature sensor, depth sensor, polling data. This is important to our project because our functional requirements require that the HROV be able to take sensory data from a set of peripherals as well as video when in tethered mode. Next, we'll go to our mechanical part of the presentation. We'll show you our current progress on our chassis, maybe talk about the issues that we've had there, some 3D printing things that we've done, some problems we've encountered, things like that. Do you have any questions so far?
Not so far.
Okay, all right, awesome.
I'll briefly introduce what you're about to see in the software demo.
Okay.
For each, you can set it down.
Okay.
For each sensor, and I'm not going to explain the code, but just for reference in case.
Yeah, I don't want to see the code. I want to see the demo.
Okay. So we'll do the IMU, which will be first, temperature sensor, GPS. Well, of course, we'll read data on each of these, the pressure, and then the sonar finally. So if you come over here, I just got it in a switch case statement, so you can select. It's just a menu basically. So for the IMU data, select one, enter. There's the IMU data.
So which device is your IMU?
This guy.
Okay. So. All right. So that's you had. Do it again.
Oh, sorry. You see the pitch change from 125 to 16.
Yep.
Some roll and some heading.
Yeah. Okay.
So that's updating.
Okay. That appears to be rightish.
Temperature feels like 73-ish, 73.4.
Yeah, it feels warmer than that to me, but that's okay.
And then GPS, since we're not next to the window, it's not getting the latitude and longitude. But if we move closer, that will be updated.
What
But
does it tell us?
I do have time that is keeping track of.
So it just tells us it's bad data. Okay. All right. Well, that's fine. All right.
And for the pressure data, we'll be reading just atmosphere, roughly 1 atmosphere of pressure.
Okay.
I also have some temperature on board.
Okay.
Onto the, and the last one is a sonar. So if I point it to the ceiling, it should read about a meter, 1.25 meters. And its shortest it reads is about 20. So if it's closer than 20, it'll read something high. There's 42. 131.
I'll buy that. Okay. Cool.
And that's it for software. We also have the camera up and running. Fairly straightforward.
Yeah.
We got video.
All right.
That's it.
Cool.
On to mechanical.
We're gonna look at mechanical things, huh?
So this is our basic structure. So we have these two bars here, which will hold the enclosure. As far as how far apart they are, that's once we get the enclosure that we'll be able to space that out. But the main thing we wanted to show was we 3D printed this, and this will be the mounts for the enclosure, the gripper, and the 2 lights. And so it fits perfectly in there. As far as how big this is, we need to make it bigger. So this was just our first prototype, so that the holes will be outside. But other than that, we just wanted to show that it fit in there pretty tight.
We put that on our error list for sure.
And then to slide it, we're gonna have, to keep it from sliding, we're gonna have these guys on each
Braces
side.
on either side.
Okay.
To hold us guys.
Okay. So this is printed that orientation?
Yeah. They told us, or Zachary printed, they said you're either going to get mess ups in the holes, or if you put them flat, then like in the grooves right there, it would get extra.
Well, the other thing that I'd be afraid of is if the printing were in that plane, then you're going to have shear off here.
Yeah, that's what I meant.
So you lose shear strength
Yeah.
in that direction.
So
and you don't
instead we
really
had it in there, which wasn't a big deal. We just took it out.
Cool. And they don't make something like the guys who make these don't make something that.
Not for that specific mount, especially because this would go perfectly into like the holes for the gripper into the enclosure, which already has holes.
So you can't buy like a plate that has this channel lock in it.
Not that I could find.
Okay, I'm just curious. It seemed to me like a logical thing to do for, you know, if I were the manufacturer of this guy.
Yeah.
But that's what I get for thinking, because I'm not a mechanical engineer. Cool. All right, so let's see. It's not as heavy as I thought it was going to be. Yes, I know it's aluminum. Yes, I know there's a lot of air, but
It could be noted that we also received the T100 thrusters, all of them for this. We ordered the enclosure and the brackets for the enclosure yesterday, the dome cap and things like that.
I have a question. I don't recall. Is this for freshwater only?
No.
It is for salt.
Yes, sir. Well, either way.
Okay. So
for buoyancy.
no.
Is that what you're gonna ask?
I'm going to ask you about these guys and your screws. How will they stand up to the corrosion of sea salt?
These were suggested specifically for that reason by Dr.
From the main competition, they suggested that aluminum would be good.
And aluminum is known for really being resistant to the elements.
Yeah. Does. So these are stainless screws. You know what grade stainless?
No, sir, I do not know. We have all the packaging, so we can get that.
No, I don't care.
It's just something to consider.
And I realize Dr. Hurst suggested it, but it wouldn't hurt for you guys to double check and see how these things are going to perform in salt water. Because the one thing that I know is that everything that you put on a boat that goes out into salt water corrodes. I've never seen anything that doesn't, and you always pay extra on boats. Okay, so it's just one of those things to kind of keep an eye on. On the other hand, by the time it corrodes, you guys will be long graduated.
Yes, sir. And our test environment is we're going to be testing it at the pools at the temperature.
Yeah, that'll be fine.
That's fresh water.
That's fresh water and chlorine, and it'll be fine.
Yes, sir.
I say it's chlorine. It might be saltwater sterilized pool. Is this a chlorine pool?
I've accidentally drank some. Don't worry.
Okay.
Jumping in, cannonball, get it in your nose. It's not salt water. That would have hurt a lot worse.
Actually, have you ever swum in a pool that's been cleaned with salt?
It's comparatively gentle.
Yeah, I hadn't noticed, other than if it doesn't taste like chlorine, any difference. But
Yeah. So we get for accidentally drinking the water, I guess.
yeah, cool. All right. So you're making significant progress. You've got motors in, thrusters.
Yes, sir. Some areas that we ran into so far with on the software side of things, the system integration, the Xbox controller isn't working as expected just yet. We're still interfacing with that to try and get it to work.
Okay.
We were, at the time of this creation, having issues with the SDI, the HDMI converter adapter. We've since then, in the past little bit, figured that out. So no issue there. That's actually one less. And then the 3D mounting brackets, they need that modification that we showed. Screws need to be enlarged so it doesn't wiggle as much, things like that. One thing that we kind of ran into time-wise that we weren't expecting was the Zachary 3D printing process is very, very tedious and not very organized. It's kind of been a lot of issues back and forth. A lot of email threads, losing of parts, losing of applications. We've kept David Malloway in the loop, and he plans on helping us in any capacity that he's able. He's very, very busy printing things constantly.
Oh yeah, no, I understand. Cool.
So we're going to work to get those as soon as possible, and then still keep fighting Zachary until we eventually get what we want, get what we need.
All right, very good. Thank you.
All right, thank you.
All right.